in order to kind of put those challenges to the test, we have been working on a proof of concept for the British Library. And what this does, this has been developed by Joscha Jaeger, who is from a company called Filmic Web, who make a product called Frame Trail. That was demonstrated on one of the AV calls a while ago, and it kind of has a very similar conceptual model to IIIF AV. There's a similar kind of model to having a canvas, which media is annotated onto. There's a platform for textual annotation of audio and video. So many of the concepts in IIIF AV are kind of, it could be applied to. Joscha was really keen on learning more about IIIF AV and participating. So we got together and worked on these proofs of concept, which basically take some of the use cases and kind of boil them down into a kind of pure set of fixtures which use test pieces of media. And I'll just jump straight in and go and demonstrate some of this stuff. So I'm going to start with some video. So although there's audio here, I'll just to make this reasonably easy to deal with, I'm going to play video. So here we have a manifest that contains one canvas. The canvas has a duration of 2 minutes, and onto that canvas are annotated 3 different pieces of video. And if I start playing this canvas, which is a new kind of concept for IIIF, I can pause and play the canvas, and you can see these two things are nicely synchronized. I can control the clock position for the canvas as a whole, so I can jump forward to say 37 seconds, and that should catch up. Or I can jump forward to a point where one video appears and another one doesn't. So you can see, if we looked at the manifest for this example, we'd see that in this canvas, those 3 annotations, one of them is for the whole duration, one of them is for half the duration, and the other one is for the second half of the duration. And this technical proof of concept is just kind of demonstrating that we can control the playback of these things on the canvas. Here's another example which has some textual annotations on a piece of video. So you can see here there's a piece of video playing, and at various positions there are text annotations that have been added. I don't know if you can hear that noise, but I can hear it. So you can see here the various annotations that have been annotated onto the canvas. We can take that a bit further and do some kind of multimedia style things. My browser might have crashed. Can you still hear me all right?
Yep.
Yeah. Yes. Yeah. Okay, so I was just having a problem with GitHub there. Try this one again. Okay, here we go. So this one is an audio example. In fact, this is actually from the Avalon team. So this is kind of demonstrating that PL's proof of concept can play media produced by the Avalon team. And this example has one file, but the structure inside the file is being described by ranges. So ranges are addressing particular time parts of the file. The example I was going to load was this one, which shows both images and text and video and audio on a canvas. So there's an image being annotated at 4 seconds in, a piece of text being annotated at 7 seconds in a particular position, another image being annotated at 11 or 12 seconds in another position, piece of video being annotated at another position, and so on and so forth. And again, we can control our position within the canvas and navigate through the canvas time, not just the time of the individual media. So that the viewing component is required to kind of control the position of the canvas clock as a whole rather than individual pieces of media. So that's all very well. This is a useful proof of concept, and it's available on this GitHub here. What Joscha has also done is produced a really good report into why this was implemented the way it was. He's an expert in how this kind of stuff works in modern browsers and the kinds of standards that are available and the techniques that are available. And so he's kind of summarized the use of various libraries and components and techniques in this document. So that's good from the point of view of providing a reference implementation for people to have a play with. But the next step, obviously, for the British Library is to make that work in the Universal Viewer, because that's their viewer of choice. And so what Ed's been doing is taking Yosha's proof of concept work and turning it into a component. And so if I go back to the fixtures, then we can see here, so on the Viewer GitHub repo, this same technology is being wrapped up inside a component, which then makes it possible to use in the Universal Viewer and other viewers that use the same kind of component infrastructure. And so the kind of logical conclusion of that is to see that component running inside the Universal Viewer. So here is the UV with, rather than the C-Dragon component or the old video component you used to have, for this particular piece of this particular manifest, it's evaluated the canvas and decided that it needs to use this new AV component and can therefore render exactly the same test fixtures that we were looking at a while ago. And there are some more here, so we can go and change some of the ones we're looking at and look at, say, for example, the fire example, it running in the UV. We have some problems to fix with the slight bit of distortion of the canvas going on here, but it is playing inside the UV. You can see here exactly the same stuff is happening. And again, if we take another example from Indiana, completely separate IIIF AV implementation that's playing in the Avalon system as that develops IIIF AV support, we can see here that we're also able, actually let's play the video, we're also able to play IIIF AV Presentation 3 manifests from Avalon. And so we can see these running here. So I'm going to pause this because it's cacophony in my ears. That's it really. So I'll paste a link to that list of links. Which is here. And yeah, so that's it really. Any questions? Everyone still there?
Yeah,
sorry,
that was awesome.
Very cool.
Just
You can
the-
show the tree.
Oh yeah, that's a good thing. Yeah, sorry. Yeah, so in this example, which one is it? The synchronized video.
Yeah, or lunchroom manners.
Yeah, that's the one. Yeah, that was the one I was going for actually. I got the wrong one. Yeah, so in this one, we have a canvas and it's annotated by a single choice of video files. But again, there is a range structure present in the manifest as well, using the new Presentation 3 API range structure, which we discussed a few times on these calls. And the UV is parsing that range structure and generating the table of contents. And so about a month or maybe two months ago, we had a demo of Avalon, which was playing this exact same manifest. And now we can, in the Avalon viewer, and now we can see the UV rendering exactly the same IIIF manifest using a different tree view component and a different AV component, and offering all the kind of control and canvas clock control that's required. And we can navigate our way through this fantastic video. And if I just go very quickly, I'll go to the list of fixtures and just take a look at that manifest, which is Lunchroom Manners. And you can see here that there's only one canvas, and it has a choice of video, high, medium, and low. And then it has a complex range structure here, which provides the access to the various portions of the work, and it's a hierarchical structure. And this is using the new range model in IIIF.
Have you looked at any VTT captioning annotations yet, anyway?
Not yet, no. I mean, that's kind of partly outside the scope of IIIF's, but a viewer could look, a viewer that understood VTT could search for references to VTT services or resources in that are annotating the canvas or linked to from the canvas as services and incorporate them and show subtitles that way, in combination with, or instead of, or as well as captions and subtitles provided as pure WTC web annotations as text. So the examples we were looking at earlier, where they had text overlaying the screen, they were just pure IIIF. So if we look at the fire one, say for example, we can see here in the annotations that here is a textual annotation. Sorry, this one here that is painted a particular region of the canvas for 15 seconds between second 5 and second 20. That exact same information could also be present in a VTT file. A publisher could choose to transform the VTT to annotations, to text annotations, and that's actually pretty trivial. There's a script somewhere that Rob wrote which shows that being done in about 4 or 5 lines of Python, just to transform a VTT to annotation lists. But I guess it would be up to other viewers whether they should give you the option of rendering VTT present in files. And if you're using something like media element as the playing element, which the UV is, then that shouldn't be too difficult to add VTT support if necessary.